Consider f defined over R by f of x equals 6 over 3 plus x squared, and C is its representative curve in an orthonormal system. Part 1, study the parity of f. We mean by the parity if the function is even or odd. So what you have to do is finding f of minus x. F of minus x is 6 over 3 plus minus x squared, which is 6 over 3 plus negative x power 2 is x power 2. So it is equal to f of x, which means that f is an even function. Now for even functions, is an even function. It has the y-axis as axis of symmetry. So even functions have the y-axis as an axis of symmetry. Part 2, find f prime of x and set up the table of variation of f. Now f of x is equal to 6 over 3 plus x power 2. F prime of x, this is a ratio, so the derivative of the numerator times the denominator. Numerator 6, its derivative is 0, times the denominator, the whole expression 0, minus the derivative of the denominator, which is 2x times the numerator over the denominator power 2. So here you go, the derivative is minus 12x over 3 plus x squared power 2. Now to set up the table of variation of f, you need first to find the domain of f. Look at f. It is 6 over 3 plus x power 2. Its denominator is positive, 3 positive, x squared positive. So 3 plus x squared is always positive. It is never 0. The domain of definition is R. Now you need to study first the limit at the endpoints, at negative infinity and at positive infinity. But here the limit of f of x as x tends to minus infinity is equal to the limit of f of x as x tends to positive infinity. It's equal to 6 over 3 plus infinity. It is 0, which means that C has y equals 0 as horizontal asymptote. Now, in order to find the extremum, you put f prime of x 0. When f prime of x is 0, then minus 12x is 0, x is 0. Find f of 0. It's 6 over 3. It's equal to 2. Now you are ready to set up the table of variation. X, f prime of x, f of x. Here f prime is equal to 0 when x is 0, minus infinity plus infinity. At negative infinity f of x tends to 0. At positive infinity f of x tends to 0. At 0 f of x is equal to 2. Now the sign of f prime of x is negative 12x over 3 plus x squared squared. The denominator is always positive. The numerator is positive before 0, negative from 0 to plus infinity. So f of x will increase from 0 to 2, then decrease from 2 to 0. Part 3, verify that C meets the first bisector at the point with abscissa alpha where alpha is between 1.2 and 1.3. Pay attention here, you are not asked to find the exact value of alpha, but the range. But we will start by solving this problem with the classical way to find the intersection between two functions. The equation of the first bisector is y equals to x. In order to find the point of intersection between the curve C and the first bisector, you need to solve the equation f of x equals to x. So 6 over 3 plus x power 2 equals to x. So 6 is 3x plus x power 3 means x power 3 plus 3x minus 6 is 0. In order to find the point of intersection or to determine the point of intersection, we are not going to solve this equation, but we will use the intermediate value theorem. So set h of x equals to x cubed plus 3x minus 6. H here is a polynomial, so it is continuous, and this is the first condition for applying the mean value theorem. Polynomial, so continuous. Now the second is if h changes sign. So find h of 1.2, you will find it equal to minus 0.672. h of 1.3 is 0.092. About this. Now the important thing is that maybe 0.097. h of 1.2 times h of 1.3, h of 1.2 times h of 1.3 is less than 0, since h of 1.2 is less than 0, and this is h of 1.3 is greater than 0, which means that there exists alpha between 1.2 and 1.3, so that h of alpha is equal to 0. h of alpha is equal to 0 is equivalent to f of alpha equals alpha. So the curve C meets the first bisector at the point with abscissa alpha where alpha is between 1.2 and 1.3, and this is using the intermediate value theorem. Part 4, trace C the graph of f. Now from part 2, you know that the limit as x tends to minus or plus infinity of f of x is equal to 0, which means that C has y equals to 0 or the x-axis as horizontal asymptote. Also, f has the point 0,2 as maximum. From the table of variation, the function increases from 0 to 2 and then it decreases to 0. So here is the graph of f. It has y equals 0 as horizontal asymptote. then it increases to the point 0, 2, decreases to have y equals 0 again as horizontal asymptote as x tends to positive infinity. Part 5. Study according to the real parameter m, the existence and the number of roots of the equation mx squared plus 3m minus 6 equals to 0. Now, mx squared plus 3m minus 6 is 0, means m into x squared plus 3 is equal to 6. So m is equal to 6 over x squared plus 3, which means that f of x is equal to m. So we will solve this graphically. If m is a straight line less than 0, if m is a value less than 0, this means there is no intersection between the curve and m. So if m is less than or equal to 0, we have no solution. If m is between 0 and 2, so here you will have 2 points of intersection. So if m is between 0 and 2, we have 2 distinct roots. Now if m is 2, we have one unique solution. If m is equal to 2, we have one root or one solution. If m is greater than 2, there is no intersection between the curve and m. So if m is greater than 2, you have no solution. Part 6. Verify that over 0 plus infinity f admits an inverse function f minus 1 whose domain of definition to be determined. Now for a function to have an inverse function, it should be continuous and monotonic. Now f of x is equal to 6 over 3 plus x power 2. It has no discontinuity. F is a continuous function. Also, between 0 and plus infinity, f of x is decreasing. So it is monotonic, which means that then f admits an inverse function f minus 1. Now f is decreasing. We have f of 0 is equal to 2, and the limit as x tends to plus infinity is equal to 0. Since f is decreasing, so the order of the domain of f minus 1 will be reversed. So df minus 1 is equal to 0, 2. Part 7. Calculate f of radical 3 and then deduce f minus 1 prime of 1. Now we have f of x is equal to 6 over 3 plus x squared. F prime of x is equal to minus 12x over 3 plus x squared squared. Now f of radical 3 is equal to 6 over 3 plus radical 3 power 2. which is 6 over 6 equals to 1. Now f minus 1 prime of 1. If C passes through a point AB, then f minus 1 prime of B is equal to 1 over f prime of A. Now since C passes through radical free 1, then f minus 1 prime of 1 is equal to 1 over f prime of radical 3. So let's calculate f prime of radical 3. It's minus 12 radical 3 over 3 plus 3 squared. So minus 12 radical 3 over 36 minus radical 3 over 3. So 1 over f prime of radical 3, which is f minus 1 prime of 1, is minus 3 over radical 3, which is minus 3 radical 3 over 3 minus radical 3. Part 9, trace C prime, the graph of f minus 1. Now to draw the inverse of the function f, we use an important idea that the graph of a function and the graph of its inverse are symmetric with respect to the line y equals x. So first of all, we draw the line y equals x, now which will act like a mirror for the two graphs. Now to obtain the graph of the inverse, look at the graph of function f, c. It from 0 to plus infinity, sure. It starts at 2 and decreases having the x-axis or y equals 0 as horizontal asymptote. So f minus 1 will have a vertical asymptote, the y-axis. It will start at x equals 0, the y-axis, as horizontal, as vertical asymptote, and decreases, so it ends at x equals 2. So y equals x is the axis of symmetry. It acts like a mirror for the two graphs of f and f minus 1. Now part 10, consider the function g of x equals radical 6 minus 3x over x. Find f round g of x and g round f of x. F round g of x, first f of x is equal to 6 over 3 plus x power 2. f round g of x is f of g of x. So in the place of x, we will replace it by g of x. So it is 6 over 3 plus radical 6 minus 3x over x power 2, which is 6 over 3 plus 6 minus 3x over x, 6 over x, 3x plus 6 minus 3x, it is 6x over 6, it's equal to x. Now g round f of x is g of f of x. So in the place of x, we will replace it by f of x. So it's equal to radical 6 minus 3 times 6 over 3 plus x power 2 over 6 over 3 plus x power 2, all and under the radical. It is equal to 6 over 3 plus x power 2, 6 minus 18 over 3 plus x power 2, it is radical 18 plus 6x power 2 minus 18 over 3 plus x power 2 over 6 over 3 plus x power 2. Now 3 plus x power 2, 3 plus x power 2, 18 minus 18, it's 6x squared over 6. So radical x squared, it is equal to x. Now part B, deduce the expression of f minus 1 of x. Now since f round g of x is equal to g round f of x, this means that equals to x. F minus 1 of x is equal to g of x. So f minus 1 of x is equal to radical 6 minus 3x over x.